The construction of the Backwater Dam followed swiftly upon the completion of the foundation works carried out in an earlier contract. However, before the embankment could be constructed, debris in the foundations had to be removed. The high artesian water pressures caused problems, requiring constant pumping and constant attention to the pumps. The very soft material prevented the use of dump trucks for hauling. Scrapers with their greater tractive power had to be used and were filled by shovel loader. The soft deposits were removed from the site to a completely independent spoil tip. Earlier site investigations indicated that suitable material for the construction of the dam could be obtained from within the valley, from a site below the ultimate top water level of the reservoir. Sand and gravel for drainage layers was obtained from the glacial mounds about 2 miles upstream from the dam, and till from a borrow pit adjacent to the dam. The sand and gravel was excavated by face shuffle and transported by 30-ton dump trucks over temporary roads. This was spread by bulldozer over the cleared foundations to a depth of 6 feet in 12-inch layers, rolled and compacted to reduce settlement. This drainage layer was necessary to collect any artesian water percolating into the dam foundations. Material for the rolled clay core was keyed into the grouted cutoff. An optimum compaction was achieved by the tracking of the large rubber-tired wheels of the scrapers and rolling with a rubber-tired independently sprung wheeled roller. Final compaction at the end of the day, to shed off any rainwater, was with a smooth vibrating roller. During the placing of the embankment, a huge rock toe wall was constructed at the downstream face of the embankment. It is of interest to those who know the district that this rock toe wall is about the same size as Lynn Dam and indicates the scale of construction. Rock was obtained from a quarry some 30 miles from the site. For appearance, the downstream face was pitched, utilizing, obtained with some difficulty, skilled labor with experience on previous dams. The method of construction is indicated on this diagram. The core is constructed first with a vertical drain immediately downstream to pick up any water either percolating through the core or from the compaction of the till. Mountain till, a coarse clay, is placed on the upstream and downstream shoulders in layers of 20-foot depth, each layer being separated by a filter drain of 3-foot depth. During the construction of the dam, piezometers are placed in the various parts of the embankment to record the water pressures. These pore pressure points are connected to the measuring devices in the instrument house by nylon tubing. A duct was constructed through the embankment in which the nylon tubing, 17 miles in all, from the piezometers was placed, care being taken to ensure that there was no leakage of water along the path of the duct. The piezometer shown is used within the embankment and placed in a cavity formed with this special tool. This piezometer is placed in a borehole, the water level being ascertained by sounding with electrical leads. The settlement gauges consist of metal plates attached to a telescopic plastic tube. The position of the plate is established electrically by sounding, utilizing the capacitance effect of the plate. Initially, the leads were taken to a temporary instrument house. As construction proceeded, the pore pressures connected were transferred to the measurements taken by equipment situated in the instrument house. As air is invariably trapped during the placement of embankment fill, special de-airing equipment is employed to enable water pressures to be recorded accurately. The pore pressure is recorded on a mercury U-tube. Finally, well over 100 piezometers were installed in the various parts of the construction, including upstream and downstream shoulders, core wall, foundations, and in areas outwith the dam where the water table had to be measured. Underdrains were laid through the bottom drainage layer of the dam and conveyed to a manhole in the instrument house where a continuous record of drainage flows was, and still is, maintained. The existing river channel had been diverted through the tunnel at an earlier date to permit the completion of the curtain across the valley. To allow for the excavation of the spillway channel, sheet piling had to be driven to divert the existing river flow at the exit from the tunnel. On top of the shaft, which had been completed in the first contract to provide access for the construction of the tunnel, a start was made to the construction of the valve tower. The shape of the valve tower, while pleasing in design, caused complications in the shutter fabrication and fixing. The overflow arrangements of any dam must be adequate to take the maximum possible flood likely to be experienced, and this is particularly pertinent in an earth dam. The main problem in passing these large quantities of water over the weir and down the spillway channel, where there is a large drop in level, is the dissipation of the energy of the water at the bottom of the slope to prevent the scouring out of the stream bed below the dam. To test the design, a model was constructed. Various arrangements were investigated, and it was eventually found that by installing a cascade of steps and a stilling pool, together with the carving of the side wall, the necessary control of energy could be obtained. The action of the water at varying rates of flow shows how quiescent it is at the outlet of the stilling pool, even at maximum rates. The excavation of the spillway channel proceeds. Before constructing the spillway system, it was necessary to continue the cut-off wall, partially completed in the earlier contract, below the weir and into the rock at the side of the valley to prevent percolation of water below the structure. A trench 6 feet wide and about 20 feet deep was excavated and filled with concrete. A concrete overflow weir was constructed above and tied into the concrete cut-off wall. The spillway channel was excavated in rock. The bottom of this channel was covered with a layer of no-fines concrete to collect any artesian water seeping from the rock fissures. This water was conveyed to drains laid on each side of the spillway channel. The spillway channel base was constructed in reinforced concrete and followed an even gradient down to the top of the cascade. The walls of the spillway channel were constructed in reinforced concrete adjacent to the overflow weir and in mass concrete down the slope to the junction with the stilling pool. care was taken to ensure that joints in the spillway channel were made watertight by the insertion of plastic water bars. The stilling pool was constructed in reinforced concrete, the floor being of particularly heavy construction with weep holes to reduce uplift water pressure. The embankment was gradually and continuously raised during the summers of 1967 and 1968. For obvious reasons, particularly having regard to the heavy rainfall and high humidity, it was impossible to place fill during the winter months. The mountain till was brought by motor scrapers from borrow pits within the reservoir area to ensure that the scars would be hidden from sight after impounding. These juggernauts each carry over 40 tons of material and will travel at 40 miles per hour. Rapid rates of progress were achieved, in good weather the maximum being 200,000 tons in 1 week. Lintrathen Reservoir was built about 100 years ago and until now has been the main source of water for the city of Dundee. A water main of 48-inch diameter steel piping has been laid from Backwater, bypassing Lintrathen. The route of the main is still quite visible. Satisfactory progress has been made at the dam and the reservoir is now beginning to appear. On the upstream face of the dam, broken rock has been placed to act as beaching to dissipate any wave action. The valve tower was eventually raised from the shaft, constructed under the first contract, fish and debris screens installed, and on the top a chamber was constructed to contain the heavy switchgear and hoist for raising materials from the tunnel and for operating the trash rake and emergency door. Meanwhile, the river had been diverted through the tunnel to permit construction of the embankment. The forebay channel was temporarily closed with stop log gates at the entrance to the tunnel to permit the 10-foot thick concrete plug to be placed in the tunnel immediately upstream of the shaft. In this plug was installed a scour pipe with control valve. The commencement of impounding by closing the scour valve was the subject of a visit by the chairman, Mr. Robert W. Murray, and members of the new Water Board, when the works convener, Mr. John Stewart, gave the order to close the scour valve and commence impounding. After the scour valve was closed, the 36-inch diameter scour pipe and the 48-inch diameter supply main were laid and concreted in completely. Concurrently, work was continued on the raising of the embankment and the construction of the spillway channel. The diversion of the public roadway down the east side of the valley necessitated the construction of a roadway across the top of the dam, and this in turn required a reinforced concrete bridge to be erected over the spillway channel. Topsoil was placed by dump truck and bulldozer on top of the downstream slope. This was compacted with a smooth vibrating roller. The spillway channel and stilling pool are approaching completion, and the close similarity to the design of the model should be noted. The blockwork to be placed on the upstream face of the dam was cast on site. Special concrete batching plant was erected and molds were prepared from fiberglass castings of masonry blocks. To match the stonework, which had varying degrees of color, the blockwork was constructed in 3 different colors with varying sizes of blocks. Nearly 75,000 were cast on site. The blocks were placed in position using a mobile crane on the upstream face to leave a distance of 1/4 of an inch between each, and spacers made out of blue slates were used for this purpose. A concave-shaped wave wall to reflect the larger waves was constructed across the top of the dam, the slight vertical curve being designed to allow for future settlement. The low sunshine indicates the time of year, and the wintry conditions can well be appreciated. While work stopped during the winter in placing the fill in the embankment, concrete work continued so long as the temperature did not drop below freezing point. Work commenced on the control house at the downstream end of the diversion tunnel. The excavation in poor ground required very heavy side supports. The valve at the end of the scour pipe in the control house discharges directly into the stilling pool, and it is fitted with a special deflector nozzle to dissipate the flow energy of the water. After assembly, it was tested. The change in the velocity of the water is quite apparent. The turbidity and color is to be expected, as this is the first discharge of water since impounding commenced, and there is always a degree of putrefaction of vegetation and accumulation of silt in any reservoir bottom. The Backwater Reservoir is situated 1,000 feet above sea level in the middle of the Scottish Highlands, an extremely inclement place to work in midwinter. At this period, work has had to be suspended entirely, not surprising when one considers the extreme conditions experienced. However, winter does not last forever. In the spring, the construction of the roadway across the top of the dam and the erection of masonry walls and the laying out of parking areas were undertaken. These masonry walls were constructed of the same stone as the rock toe wall of the dam. Handrails were erected at the spillway channel and other points to provide protection for the public and for the board's workmen. The depth of the spillway channel at this point is about 25 feet. Over the winter, the reservoir had been filling, and in May 1969, 9 months after commencement of impounding, the reservoir started to overflow. The uniform flow of water over the spillway does great credit to the skill of the contractors in providing a level weir. The flow of water down the spillway channel and the dissipation of energy at the steps is most effective. The construction of the control house has now been completed. The building was designed by a local architect to match the massive nature of the dam most effectively. Here are sited the control valve, scour valve, switchgear and other offices. Entry to the tunnel is obtained through the control house. The tunnel is lined with corrugated fiberglass and lit with strip lighting. The shaft bottom, containing the switchgear for the main hoist and the scour valve, is also lined with this fiberglass. The lining of tunnels of this material is a new development and gives a most pleasing appearance. The shaft is about 150 feet in height, and the effort required to climb the circular stair can well be appreciated. Three outlet valves, electrically operated, of which this is one, are placed at varying depths down the shaft. The chamber at the top of the tower is now complete and includes the various gadgets for operating the equipment installed. Preparations for the official opening of the works were now put in hand. Turf was laid, and flagpoles, stands, etc., hurriedly erected. Her Majesty Queen Elizabeth kindly consented to inaugurate the reservoir on 9th October 1969. The weather clerk was most cooperative, the sun shining brilliantly all day. Before the arrival of Her Majesty, the crowds were entertained by the bands of the Black Watch Regiment, probably the most appropriate army unit for this particular occasion. The Queen was received by the Lord Lieutenant of the County of Angus, the Earl of Dalhousie, and Mr. Murray, the chairman of the board. Her Majesty was here introduced to various dignitaries and people connected with the work. The Queen made a short speech and unveiled a plaque to commemorate the occasion. A second plaque on the gate pillar of the dam describes the work and other features of the project. The Queen was then escorted across the dam and up the valley to view the new expanse of water presented by the reservoir. Meanwhile, senior engineering and contracting members of the construction team gathered at the control house for presentation. Afterwards, the Queen pressed the button to operate the scour valve and showed a very keen interest in the effect. The completion of the backwater reservoir produces a very welcome addition to the existing reservoir at Lintrathen, in view of the increased demands for the city of Dundee and the surrounding districts. The construction of the dam was completed during a dry spell, and fortunately just in time to overcome water deficiencies within the area supplied. The very low level of Lintrathen reservoir, shown by the expanse of mud at the top end, indicates very clearly, if nothing else, the necessity for the additional reservoir. The backwater reservoir is a very fine acquisition for the new water board and considerably enhances the amenity of the district. It is the first stage of a large scheme, initially to provide water for the city of Dundee and district, but which can now be implemented to permit the improvement of services throughout a very large part of the area under the control of the East of Scotland Water Board.